Okay, so I'm just gonna be checking the sound and let's just try to see if everything is alright. And just right after that, we're gonna be able to talk about the sample curve node. Okay, so let's just check. And well, it seems like everything is alright with the sound. So let's just start. Okay, perfect. So the first thing that we're gonna be talking about is like well, we're gonna be able at the end of this video, we're gonna be able to do something like this. So for example, if I move this, it's gonna be moving according to the length of the curve. Okay. Um, and that's basically it. Well, there's a lot of other things that can be done with this, but it's just like this is the most. This is just a little example of what this node can do. Okay, so let's just create a new file. So let's just click in general and don't save this. And let's just click here. Let's just start shortcut IVR. Oh, let's just perfect. And now we have like this cube, so we can basically go right away to geometry nodes and add a new node. And with this node in mind, we're gonna just add a transform for the cube that we have right here. So let's just go to geometry. Oh, I'm sorry, X. Okay, so let's just go to geometry and transform, and let's just connect this here. Okay. So the next thing that we're gonna be doing is that we're gonna add the node that we're gonna be talking about today. So it is in curves, and it is in sample curve. Okay, and um, we're just gonna add some other couple of things before going and checking the manual to to see what it says about this node. Okay, so we're gonna be adding a vector. Let's just click on uh, combine, and let's just do it for translation. And here, let's just add another vector for separate, um, and connect this vector to the position. Okay, so now we're gonna have the information that is coming from this node. Okay, so there is no information coming from this node, so anything is going on right now. Okay, everything is in zero right now. And we're also going to be adding um, a curve. Okay, so um, let's just add a curve primitive. Maybe we can add, I don't know, like a circle if we want. And this circle, I would like to you to be able to see it. So let's just connect it also to the to a join geometry. So geometry, let's just join geometry and connect this here, and we're just gonna we're just gonna move this cube a little bit in Y. Okay. So now that we move the cube, we can oh, I'm sorry. The problem is that yeah, we're gonna be moving the this curve too. So let's just Control C, and let's just use another transform. Shift Shift D, connect it here, and let's just move this transform along the X Y. Perfect. So now we can see our circle, and maybe we can like increase its radius, um, and move it a little bit more, and that's it. Okay, perfect. So we can see what are we doing. Okay. So our next thing is that we're gonna be connecting this curve here. So well, we have everything set up. We just don't have like the explanation. But if we move this length, you're gonna see that the cube moves around the circle. Around the length of the circle. Okay. So let's just go to the manual and let's just try to check what's going on in there. Okay. So the manual says that the sample curve calculates a point on a curve at a certain distance from the start of the curve, okay, specified by the length of our factor inputs. So what it's saying is like this node, what this node does is just like it calculates a point on this curve, you know, at a certain well at a certain distance. So that means that for example the this distance that is going to be specified by the factor or by length is like um, is here most of all in the control points, you know, but like this is where it starts, but it also like if for example you can like uh, you can see like it starts here kind of, and then it moves to here, you know, that's like a little bit like 5.9 meters later, and then it moves to the top that it's gonna be here like almost 12 um, meters later, and then it moves to this point that is here that is 17.5 um, meters. Okay, so that is what it's gonna be depending on, like on the position of this information um, on the curve. You know, if for example we just like if we just tell this that we don't want it to be handling the information in the x axis, we're gonna see that it's just only gonna be moving according to the position of the length of the circle in the y-axis. Okay, because it also doesn't have any movement in the in the in the z-axis. If we want to like try to I don't know, like try to add some different position in the z-axis, what we can do is that we can just connect this here, and it's gonna be, well, first of all it's gonna be like changing of course the position of the cube, but it's also gonna be happening something really important, and it's that um, if we rotate it, for example, in the z-axis a little bit, okay, in the y-axis, if we rotate it a little bit in the y-axis, right, that it's gonna be just making a change in the z-axis also. Then every time that it moves in the z-axis, like it's gonna be there, you know. So let's just for example connect this and this, and let's just see what happens. You see, it's gonna be moving around the z-axis according to the curve. Okay, let's just see what else the manual says. So it also says that it also outputs data retrieved from that position on the curve. The sample values are linearly interpolated from the values at the evaluated curve points at each side of the sample point. Okay, so what this is saying is that this is making, of course, an interpolation because it's like a curve, and that interpolation it's coming from like from the values at those curve points, you know. So um, for example, if we just go to Blender again and we try to just to check like the let me just see if we can see it with the wireframe. No. Like if we try to okay, let's just go to. Of course, we're not gonna be able to see it with edit mode. Edit mode. So, in order to be able to see this, and actually, I just would like to show you a different example. We're gonna be disconnecting this here, and we're just gonna add a curve. So, for example, let's just add a curve, a Bezier segment, and let's just grab it in Y, and then let's just try to like. Well, the first thing of this is that if you, for example, scale this curve, of course you're gonna need to apply that scale, and then you just go here and add an input that it's gonna be an object info and geometry, and then just connect it here. Okay. Um, well, it's gonna output like another curve also. Um, let's just disconnect this and maybe this transform too. Okay, so let's just connect this here. Perfect. So the thing that I wanted to show you is that this interpolation it's gonna be done according to like um, the position of, for example, in this case, these two different points. Okay, and of course its handles. So it's gonna be just interpolating according to those points to arrive to the second point. Okay, and if there are more points, well, to arrive to the third and fourth and so on and so on. And there's also something really interesting here, and is that if you go to edit mode, you're gonna be having here these tools, so you can like write down this other segment, and you can see here that in the spreadsheet editor, there's like another spline now, and then if you add another one, you're gonna see that now there are three. So what is going to happen? Because this is the same curve and this is taking information of that curve. What is going to happen is that you're going to be having this object taking the information spline by spline, you know? So every spline is going to be a new information. So this is really interesting if you want to move this curve. You see this cube. So the first spline that is taking is this spline. That is the first one that we created, and it's the first one in the spreadsheet editor. Is this one, and then it's gonna start with this one. You see, and then it's gonna start with this one. Okay, so that is really important, and that is also gonna be like some information that the manual is gonna be talking about. Let's just check that. Okay, so here it says like there is like a note. So when the curve contains multiple splines, the sample position is found based on the total accumulated length, okay, including the lengths of all previous splines. The order of the splines is the same order as displayed in the spreadsheet editor. That is basically what I just told you. Okay, so the inputs are going to be like the curve. So this is a standard geometry that needs to be a curve. Um, there is also like a factor, and it says like the portion of the total length used to determine the sample position. So what does it mean? Like, for example, we have like here the option of of the factor, and that option it comes from 0 to 1. That means that it takes the total length of the curve and it divided like just to be, I mean, for you to put like a 0 or something between 0 or 1, you know. So that's it. Okay. In the length, you're gonna be able to find that. well, I mean, it goes according to the length that you put in here. Okay, so if you put it like I don't know, 14 meters, then it's gonna be taking the information of the curve at 14 meters, adding like the information of the first curve. I'm sorry, of the first spline, the second spline, and so on and so on. Okay, so let's just see what else the manual has to say. Um, then it says like that. Well, the length, a length in distance, it's in distance units used to determine how far along the curve to travel before sampling. Okay, that's what I just told you. Okay, um, and then the properties. Okay, then it says like there are two modes how to find endpoint positions for the trimmed spline. The option acts the same as it does in the trim curve node. So what it's saying is like it has like the same option here. Like this is the trim curve node, and it has the same option. And it says like that. Well, in Factor, you can find the endpoint positions using a factor for each spline length. The input values should be between 0 or 1. That's what I told you. And the length, find the endpoint positions using a len from the start of each spline. The input values should be between 0 and the length of splines. Okay, so that is just depending on the length of the spline. After you reach the end of the spline, you're gonna be able to see that the cube is not gonna move anymore because it's not gonna have. I mean, it is already at the end. Okay, so what else? What else the manual it has to say? So mm, okay, let's just check. And then the outputs. Okay, so first the position, like the position at this sample along the spline. So it's just like giving you the position. For example, if you connect um, if you connect the only the x axis, then it's gonna be giving us a position only in x. That's what it's gonna. That is the information we're gonna have. Okay. If we connect the y-axis, then it's, for example, in this case, it's gonna be giving us x and y. Okay, so you see that it doesn't move in the z-axis. But if we give it like x, y, and z, then we're gonna be having the whole movement in X, Y, and Z. Okay, and I guess you can play around with that. Okay, you can like I don't know, like for example, connect X here and Y here, and let's just connect Z here and okay, something like this. So it's gonna be giving you like a weird positioning for this cube. And well, that's it. And let's just see what else the manual has to say. Um, so here we can like well, there's another output that it's the tangent of the curve at that position, at the sample position. And here is a tip that says that this output can be combined with the aligned Euler vector node to create a rotation that lines up with the direction of the curve, including the normal output in a second aligned node after can align the other rotation axis. Okay, we're not gonna try to check that right now because we don't know yet these nodes, but we can do it like later. Then the normal, it says that then it is like the normalized curve normal at the sample. Then we have some example. Here is like well, here it says that the count mode for the resample curve node that we already checked is recreated, except a mesh is used for the result instead of a curve. The z-axis of the position can be used as the sample factor because the position is between 0 and 1 for the entire line. Okay, so what this is saying is that basically here there is a mesh line that it's going to be like entering, and then it sets the position, and in that position is going to come from the sample curve, and there is a curve that it's like this one that you can see here, and there is a curve, and that curve comes here, and then there is another position, and that turns into a vector in the z-axis, and there's a factor. The z-axis is the factor because it's like between 0 and 1, like basically 0 all of the time. And then you have like that factor, and then you can see that it gives you like some sort of mesh, a mesh line, but that is, it has like the positions of this curve. Okay, so well, I guess that'll be basically it, and I hope to see you on the next time. Thank you for watching this video. I hope you can like it and subscribe and all of that.